y-axis. So we're going to go ahead and find the intercepts. These are the same equations you worked on yesterday. So if you remember, I told you guys as you were finding the characteristics of the graph that we weren't going to emphasize them as much, but we were going to specifically ask for things like domain, range, x-intercept, y-intercept, and just like that hk value. So just a reminder, and I'm going to start with y-intercept. The y-intercepts tend to be simpler. I'm not going to say you're always going to get them right, so don't think like, gosh, I miss them every time, missed all things, okay? That's not what I'm saying. I'm just saying all of our equations are set up in the format usually of y equals, which means they're already ready to tell you what y is. So, for example, in your quadratic, the f of x is really your y, and remember to find intercepts, you're plugging in 0 for the other variable, so in this case x, and looking for y. So the reason I say y is simpler, and that doesn't mean it's simple, just simpler, is because of this. Notice that everything you have to do is on one side of the equation. You don't have to solve anything. You just have to remember the correct order of operations and finish the calculation on the right side. So we want to make sure we start with the 0 minus 5. And then here's where a lot of people make mistakes. You need to complete your exponents before you do multiplication. So I need to square the 5 before I'm multiplying by 2. So then this becomes 50 minus 4, which is 46. So my y-intercept, the point where I would expect this graph to cross the y-axis, would be at 0.46. And if you have a picture of that graph and look back at it, it should be pretty steep getting close to the y-axis because we probably don't have it numbered to 46. So it should be like, whoa, it's got to go over a ways and it's really steep, and that's how it will hit 46. Okay? So let's do the same thing for the cubic. Let's go find its y-intercept as well. Okay? So, we're going to plug in 0 for x there. And you have a lot of work to do in the parenthesis here, so you need to multiply 2 times 0, which would be 0, and then add 6. So you have a negative outside of the power. Then you have 6 being raised to the power of 3, and then minus 4. So 6 raised to the power of 3. And if we were taking a test, and since we're doing it no calculator, if it was like too big you feel to calculate, then you could leave it as 6 to the third minus 4. 6 to the third is actually 216. I do numbers all day, so I do know that one. And we get negative 220. So the y-intercept for this function would be 0, negative 220. And if you remember what this cubic looked like, it actually makes sense because it was really narrow, right? Super duper steep. It almost looked vertical. So it's going to go down really far before it ever hits the y-axis. Okay, so what makes the x-intercepts a little harder is that x is not already solved for. Okay, when we plug 0 in for y, these equations are a little more difficult to deal with. So how are we going to approach this? I can't just go do a calculation because it's not all the numbers on one side. I essentially need to get x alone. So what's going to be my strategy to do that here? Good. Okay, so I'm going to start by moving over the 4. And then what should I do? Good, divide by 2. So notice what they were trying to do. They're really trying to get that squared part alone. And what is the purpose of getting the squared part alone? How does that help me? Okay, so we could factor, and I want to make a side note about this because in your weekly review, you had something like this. So I just want to clarify, hopefully. If I could ever get it to do what I want it to do. Okay, off to the side. You guys don't have to write this down. If I have something like this, okay, and it's set equal to 0, I want to solve this by either factoring when it's set equal to 0, or if it doesn't factor and I can't do this, then I want to use the quadratic formula. Okay, so if we want to work on what Grace is saying, we could use factoring to solve this, but not when it's equal to 2. We would have to bring the 2 back over and set it equal to 0, which means we'd have to multiply out the whole x minus 5. That's not wrong. You can totally do that. However, something that's special about the way this is set up versus the one I just showed you is that all of the x's are right here together in this squared. So think about a simpler problem. If you had all of the x's together being squared and you just had that equal to a number, how could you solve for x in this problem? Yeah, we could take the square root. You can do that same thing in this problem here, because all the x's are still in the squared part. There's no other x's randomly with other numbers in the problem. So we can square root both sides of this. Be careful when you square root. This was on your last weekly review, and a lot of you got one of the answers, but not both. Because if I tell you guys I'm thinking of something squared and it comes out to be 4, what number am I thinking of? We tend to want to say 2, but what other number could I be thinking of? Negative 2 squared still equals 4. So that's why I had to include the plus or minus here. And then I'm going to add 5 to both sides. So it's not going to look really nice, but it's a 5 plus or minus a rad 2. How many x-intercepts is that? 2. Can a parabola have 2 x-intercepts? Yes. Are these super nice, convenient numbers to graph? No. Okay, it's like 5 plus 1 point something and 5 minus 1 point something. But if you want to at least make sure that they make sense, think about 5 plus 1 point something and see if that makes sense with your graph. So you can actually write these still as points. I know they look a little funny. But here it is. And that's actually 2 points because of the plus or minus. Yes? No. Okay. Just the graphing part, because you guys don't have time to practice it today. All right, so let's do the same thing for the cubic function. So we're going to take that same idea, and this is the last example we have, and then you guys will get to work. All right, so somebody new, tell me the first step I'd want to take in solving for the x-intercept in this cubic function. Good, so I'm going to add 4. And then somebody else, what should I do next? Chance? Good. A negative 1, is that okay? So I'm going to have negative 4 equals 2x plus 6 cubed. Now, it's really good that this was a cube. If you ever had this setup and it was a squared, could negative 4 ever be equal to something squared in real numbers? No, you'd stop if it was a squared and be like, this is not possible. There aren't any x-intercepts. Or you could keep going, but you'd end up with a negative under your radical. Okay. What am I going to do now, though? Cube is okay. Can you cube things and get a negative? Can. A negative number cubed is a negative, so I just kind of expect whatever's in this cube to be negative. What should I do as the next step in order to find the x value? Take the cube root. Okay, so just like my square root, but instead, it's a cube root. So I have the cube root of negative 4 equals 2x plus 6. 4 is not a perfect cube, so I can't really break it down. However, I will say if you guys left it like this, I wouldn't mark it wrong, but usually people would put the negative on the outside because they know the cube root of negative 1 is a negative 1, so the negative can come outside of the radical, but we can't break 4 down into 3 of the same factors, so we can't take any piece of 4 outside of the radical. And then that equals 2x plus 6. And this is going to look a little ugly, but we're just going to be okay with it. Right? We're just going to keep working through the problem like we would, where the last step is to divide by 2. I'm going to write it over here because I'm out of space. But x is equal to, so we have this negative cube root of 4 minus 6 all divided by 2. Okay? And you can write it like that. You can put it in the point if you want. If you're like, hey, the 6 and the 2, we can simplify them. We can, and you could make that second term a 3, but then you would still have to have that 2 underneath your cube root of 4. Remember that 2 is a denominator for both of them. So if it can simplify with one of them, that's great, but you still need to write it in the other term as well. Okay? Is this okay for a reminder of how to solve things like this? Okay, and because they're grouped together, we actually don't have to use factoring or quadratic formula. We can just go ahead and cube root and square root them. All right? So we're going to let you guys work on your homework.